It's steam time. It's steam time. It's steam time. Hey, hey, hey. It's steam time. It's steam time. It's steam time. Hey, hey, hey. Last time on the Great Boiling Steam Challenge. To give you a better visual of what it looks like when warm air rises and the cold air falls, causing shaky and humid air for a thunderstorm, let's take a closer look. As you can see, the cold air is sinking down and the warm air is on top. Now, back to your STEAM Challenge program. Well, hello, STEAM scholars. Sunny and I are ready to explore more about thermal energy and heat transfer, specifically convection and radiation. Are you? Let's bring on the heat. To begin, we will start by going over the design process, followed by saying what STEAM stands for. The design process is something we as engineers and scientists use every time we create or do an experiment. Feel free to say each step with me. With any project, we are going to A, ask, what is the problem or what am I trying to create or solve? B, brainstorm, how can I solve or make what I'm trying to create? C, collect information, data, or use prior knowledge to help you create. D, develop, start creating your project. E, evaluate, what works, what doesn't work, and what can I do to make it better? F, fine-tune, I will try again until my design is where I want it. STEAM stands for science, technology, engineering, art, and math. Great job! It's student question box time where we want to hear from you. Last week, the questions read, why are some things hot and some things cold? How does my warm hand become cold when I touch something cold? What makes things frozen? Why do things melt? Remember to keep these questions in mind as we will explore these questions and more all throughout this unit. Last time, when we met, we went over the 3 ways heat transfers. Heat transfers by conduction, which is heat by touch, convection, heat transfer by air, gas, or liquid, and radiation, heat transfer through electromagnetic waves. We learned that conduction is the heat you feel when you touch a hot object. In our challenge experiment, we made a hypothesis and discovered which conductors made the ice melt the fastest. Remember, heat is energy that flows from hot objects to cooler objects. Energy is the ability to do work. We learned that the energy an object has because of the movement or vibrations of its molecules as thermal energy. The movement of molecules causes objects to be hot or cold. The faster molecules move, the more energy it has, which makes for a hotter object. The slower the molecules move, the less energy it has, and the colder the object. Today, we are going to focus on convection. Convection is heat transfer, which means to move from one place to another by fluids such as air, gas, or liquid. An example would be cooling yourself off with a fan or the steam from a hot bowl of noodles. With convection, the air moves in a circular motion. Cool air sinks and warm air rises. Can you think of other examples of convection that you may have experienced at home or school? Take some time to discuss with your class now. Way to go, STEAM scholars! I thought of steam from hot chocolate or a hot bath, the air that falls from an air conditioner, the steam of boiling water, or even how air changes during thunderstorms. Remember, with convection, heat transfers moves from one place to another by fluids like air, gas, or liquid. If you remember from the recap video about thunderstorms, it showed how warm air rises and cold air sinks. But don't just take my word for it. Let's become scientists and test it out ourselves. Before we begin our Now That You Know challenge, let's think. What do you think makes warm air rise and cold air sink? Sensational ideas, Team Scholars. I love seeing your brain work. Now that you know more about how heat travels by convection, let's test it out. Remember, convection is heat transfer, which means to move from one place to another by fluids, such as air, gas, or liquid. With convection, the air moves in a circular motion. Cool air sinks and warm air rises. For this challenge, we are going to conduct our own experiment to see firsthand how molecules move in cold and hot water, and then test how heat rises and cold air sinks. It is steam time, so let's get started. For this project, you will need 2 plastic jars, hot water from your electric kettle, cold water, 2 pipettes, red food color and blue food color, a clear straw, a pencil, your design process notebook, and 2 cups, 1 to put your hot water in and 1 to put your cold water in, and your plastic pitcher to hold your cold water. Step 1, you're going to pour your hot water into a jar about halfway. And in your other jar, you're going to fill it with cold water. Now you are going to fill one of your pipettes to the first line with blue food coloring. And fill your other pipette to the first line with red food coloring. In the jar with the cold water, drop in the blue food coloring. And tell me, what did you notice about the way the blue food color dropped in the cold water? Draw what you observed in your design process notebooks. In a jar with the hot water, drop the red food coloring. What did you notice about the way the red food color dropped in the water? Draw what you observed in your design process notebooks. Looking at both jars, what do you see? Do you spot any differences on how the blue food color reacted to the cold water and how the red food color reacted to the hot water? Which jar dissolved the food color the quickest? Why do you think that happened? Now take your straw and place your thumb over the top of the straw. Place your straw halfway in the hot water. Quickly release your thumb and quickly return to gather hot water in your straw. Be sure to keep your thumb tight on the straw as you are removing it from the hot water. Keep your thumb tight. Now place your straw a little further down from the halfway mark in the cold water jar. Quickly release your thumb and quickly return it. Remember to keep your thumb tight as you are removing it from the water. What did you notice in your straw? Do you see the colors not mixing? Do you see how the hot water stayed on top and the cold water stayed on the bottom? That is because in convection, hot rises and cold sinks. Now, let's try the opposite way to see what happens. You can place the water in your straw in your empty cup that you have. This time, we will do it by putting the cold water first and then the hot water. Place your straw halfway in the cold water. Keep your thumb over the straw. Quickly release and quickly return your thumb to gather the cold water in your straw. Now place your straw a little further down from the halfway mark into the hot water jar. Quickly release your thumb and quickly return. Why do you think the reaction was different this time? Take time to have a class discussion about your thoughts and write or draw what happened in your design process notebooks. As you can see, the hot water that we put last is now going to the top, and the cold water is kind of going to the bottom. So that is all for today's STEAM Scholars. Today, we took a deeper dive into one of the ways heat transfers through convection. We learned that convection is the transfer of heat that takes place by air, gas, and liquids. Next week, when we meet on Zoom or Google Meet, we will do a 3D art project to show an example of radiation. Radiation is the transfer of thermal energy an object has because the movements or vibrations of its molecules through electromagnetic waves. Radiation doesn't rely on the touch between the heat source and the heated object. It gives out heat, like when you feel warmth from a campfire. Never stop asking questions, and remember to write any new questions or thoughts you have in your design process notebooks. Until next time, my STEAM Scholars, be great and keep exploring. Bye-bye.